More than 38 years have passed since the Chernobyl tragedy, the largest accident in the history of nuclear energy. You probably know this story. Reactor explosion, fire, and huge amounts of radioactive materials released into the environment. After the disaster, the entire population of the exclusion zone, more than 350,000 people, was resettled. Deaths from the immediate consequences of the disaster amounted to up to 50 people, and from the long-term effects of radiation, about 4,000, and this figure continues to grow. The lands around the station will never return to their former state. The accident changed nature, affecting all living beings, but not wild boars. Today they live in an area with the same level of radiation as on the day of the disaster, as if radiation does not affect them. I'm sorry, my throat is dry. Drink some coffee and we'll continue. And don't forget to like it if it's yours, at the end of the video or during the viewing process. So, the facts. The Chernobyl disaster in 1986 led to a significant release of cesium-137, a radioactive isotope with a half-life of about 30 years. Given that more than 3 decades have passed, scientists expected that the level of cesium in the infected areas had decreased by at least 50%. It seemed logical. The expectations were fulfilled for many animals, and their pollution levels actually decreased year after year. There is a simple explanation for this. The cesium gradually dissipated, was washed away by rainwater and bound to minerals or went deep into the soil, from where plants and then animals stopped absorbing it. However, in such volumes as before. Studies have shown that most of the food samples from the exclusion zone show not just half of the initial concentration of cesium, but much less. But everything was going smoothly before the bore check. The scientists were pleasantly surprised when they found that their radiation levels remained at the same level, as if the disaster had happened the other day. 30-odd years? What 30-odd years? The radiation level in wild boar meat is so high that it is unsuitable for consumption. It is simply dangerous. Scientists were shocked by this anomaly. Chernobyl's wild boars have become a scientific mystery. Some scientists have suggested that cesium accumulates better in adipose tissue, but studies have not confirmed this. However, it turned out that wild boars seem to have violated the laws of physics. This phenomenon is called the wild boar paradox. The mystery was solved only in 2023. A group of scientists was able to identify the source of radiation using modern technology. It was difficult, but the results stunned everyone. It turned out that another isotope of cesium, cesium-135, was found in wild boars, which was not related to the Chernobyl tragedy. This isotope has a much longer half-life, and it is very difficult to detect it. A logical question arose. Where did cesium-135 come from in wild boars, and why is the radiation not decreasing? Scientists have concluded that this is due to the diet of wild boars. They talked about this, for example, about Bavarian wild boars, but they believe that the conclusions apply to Chernobyl as well. The fact is that wild boars mainly eat deer truffles, mushrooms located at a depth of 20–40 centimeters underground. Cesium penetrates the soil slowly, so the underground truffles began to absorb the isotope released as a result of the Chernobyl accident. In addition, the mushrooms are still infected with other cesium isotopes. Cesium-135 got into the soil back in the 1960s during nuclear weapons tests. Studies have confirmed that a high proportion of cesium in wild boar meat is associated with these tests. In some samples, the level of cesium reached 68%. The mechanism of cesium entering wild boar meat is the same. Slow penetration into the soil, absorption by fungi. But cesium-135 had 25 years more time to accumulate, so deer and truffles are just beginning to be exposed to the consequences of the Chernobyl disaster. I wonder if mushrooms could be surprised. They would be surprised. And yes, the same situation is observed in Germany. A significant part of wild boars in Germany are radioactive. The degree of radiation is so high that local hunters have to provide meat to the authorities for inspection. This is not because of intrusive control, but to identify potentially dangerous meat. In this case, it should be disposed of. Some hunters even gave up hunting wild boars, which, in turn, led to a new problem: their spread. Yes, it's not that simple in this world, but think about it. This is a really unexpected problem. Do you expect radioactive wild boars to be in the exclusion zone but in Germany? In the beginning, scientists could not understand how this was possible. The reason turned out to be the same: nuclear tests in the 1960s and the diet of wild boars that eat truffles. Radioactive truffles keep the contamination level in wild boar meat at a high level and will do so for a long time, as the cesium must completely disappear from the ground in order to stop the contamination cycle. A similar fate befell reindeer in Norway. It would seem that almost 40 years have passed since the Chernobyl accident, but its consequences still affect deer. They continue to be radioactive. In April 1986, the wind blew radioactive particles many kilometers away, and 700 grams of cesium-137 settled in Norway as a result of prolonged rains. For this isotope, 700 grams is a lot. With the rain, radioactive materials entered forests and lakes, polluting the environment, berries and plants. They also reached lichens, fungi, algae growing on trees, and a favorite treat for deer. Lichens, having no roots, receive nutrients from the air, which makes them ideal for absorbing radioactive cesium. As a result, the deer, without suspecting anything, ate poisoned lichen and became radioactive. In 1986, scientists determined this, and in 2014, an inspection conducted again showed that the deer were still radioactive. Okay, the meat contamination has been dealt with. What about the more interesting aspects? According to popular culture, radiation should produce terrible mutants, really dangerous monsters. In theory, they should live in the exclusion zone because their ancestors received an excessive dose of radiation after the disaster at the nuclear power plant. And some of these myths are true. Radiation shock from the reactor explosion and chronic radiation exposure led to morphological, physiological, and genetic abnormalities in all the animals studied. Populations in the exclusion zone are deformed, but not to the level of monsters. It is known that animals died much more often after the disaster, and the reasons were similar to the changes that occurred in humans: tumor growth, immune defects, shortened life expectancy, early aging, and so on. But that didn't turn them into monsters. Some managed to survive. These are dogs. The DNA of the crowned dogs collected during research at Chernobyl turned out to be the descendants of those who survived the disaster. In general, there are no mutants in the exclusion zone, although the animals are different from others. They are usually bigger and not afraid of people. Chernobyl animals were not afraid of humans because they simply had no experience of interaction. This applies to wild boars, foxes, wolves, roe deer, hares, numerous birds, and even bears. We can say that the Chernobyl disaster benefited the animals, at least except for those who died from radiation. The number of animals in the exclusion zone has increased significantly since the accident. For example, the number of roe deer has increased tenfold in 10 years without humans, and the density of wolves in the exclusion zone is more than 7 times higher than in other similar areas. Scientists attribute this to the absence of people. But why didn't the scary mutants appear? The reason lies in the timing of animal reproduction. Radiation as a mutagen has a good effect on microorganisms and animals with a short period from birth to the provision of offspring. Larger organisms, even with the size of a vole, are more likely to die from radiation. In order for a substance to increase the number of mutations, it needs to go through reproduction, while receiving a dose at which the body will not survive. So no saber-toothed rats or deer with tentacles. Everything is quite casual. However, against the background of other isolated wild boars turned out to be especially tenacious. It was not an instant survival. The number of all animals decreased with increasing radiation. Everyone had their time before they faced their early death, but it's important how they used that time. After the Chernobyl disaster, all animals faced the need to survive, and wild boars are masters at this. Everything that nature has provided has helped them survive in difficult conditions. Wild boars adapt easily and can survive in anything but everything. due to their good fertility, early maturation, and omnivorousness. They are not afraid of heat and cold. This makes wild boars one of the most successful species on Earth and has helped them survive the disaster. To better understand this process, let's compare a wild boar with a roe deer. Suppose both of them lived near the Chernobyl nuclear power plant. A pig can breed all year round once it finds a male. Every 12 to 15 months, females bring 2 litters, 7 piglets each. After 6 months, the piglets can already reproduce and the cycle continues. Now let's say that the pig has, say, 2 years of life left. She doesn't know about it and starts mating immediately after meeting the male. After 18 weeks, 5 piglets are born, and although radiation could have affected them, after 6 months they can all start reproducing, just like mom. Wild pigs always manage to reproduce, even with a short lifespan. What about the roe deer? These animals breed once a year, and their mating season lasts from July to August. Pregnancy lasts 10 months, and usually only 2 fawns are born. To be ready to breed, roe deer need another 6 months. And remember, their breeding season is limited from July to August. That is, almost a year must pass from the moment of birth before the female can become pregnant. And since the disaster occurred in April, the roe deer could not get pregnant immediately after that, because there was no suitable time. Even if we leave April, the situation looks different. While wild pigs rejoice for several generations, roe deer barely gave birth to 2 cubs, and it is not clear if they will even be able to live until next year to reproduce new offspring, since they do not have good adaptive abilities. As a result, wild pigs gained a clear advantage over other species. Yes, they also died from the consequences of the accident, but their ability to reproduce quickly made them much more successful in dangerous conditions. And it's not just Chernobyl's wild pigs that have discovered their survival rates. Do you remember the Fukushima 1 accident? It happened in 2011, and still 20 kilometers around the station remains an exclusion zone. This place is dangerous for humans, but not for wild boars. They're doing well there. Studies have shown that after the accident, the local wild boar population increased significantly, from 3,000 to 13,000 in just 4 years. Wild boars use abandoned houses and buildings in the area as breeding grounds and shelters. The most amazing thing is that even though the meat of these wild boars contains 300 times the safe amount of cesium-137, they do not show any special signs of harm from radiation. Some farmers even complain about their presence. The local authorities offered hunters a reward for the boars they caught. But if you've watched our videos about wild boars in the USA, you know that such males breed so fast that no hunter can keep up with them. Oh, wolves against cancer? It sounds like a low-quality movie title, but it's true. The wolf population in the Chernobyl zone differs from its relatives outside the region, and this, in general, is not surprising, not because of radiation. But here's what's interesting. More recently, scientists have discovered that irradiated wolves appear to have developed protective mutations. Although excessive doses of radiation lead to radiation sickness and cancer, the opposite has happened in Chernobyl wolves. They have mutated, and now they are resistant to cancer. Scientists are already thinking about how to use this discovery to treat cancer in humans. New horses of Chernobyl. A few years ago, 36 Przewalski horses were brought to the exclusion zone. These are exactly the horses that many consider to be one of the few truly wild animals. They once became extinct in the wild, but were reintroduced and later relegated to an exclusion zone. It turned out that it was a smart decision. In the territory freed from humans, the population of Przewalski's horses has increased significantly. They even use abandoned buildings as shelters. They decided to turn the exclusion zone into a nature reserve in order to save horses from the threat of extinction. Who would have thought it would work? Radioactive pets. At the height of the events at the Chernobyl nuclear power plant in 1986, thousands of people fled their homes, leaving their animals behind. The descendants of those dogs and cats still live in the exclusion zone, and now the local authorities are deciding to help them, quarantine them, vaccinate and sterilize them, and then send them to new families in the United States. Do you want a radioactive puppy? I would like it, at least for your willingness to accept it. See you soon.